Hi everyone. So in this video, we're going to go ahead and start to introduce some of those ideas of chemistry, states of matter, and then also different size scales so we can view chemical reactions. Okay, so first of all, chemistry is often known as the central science because it helps to relate biology and physics and all the other sciences. So chemistry is the study of matter and how it changes. And matter is quite simply anything that has mass and takes up space. So this is going to be most of the things that you're interacting with every day. The chair you're sitting on, the computer that you're using to view this video, any paper or pencils, things like that, that is all matter. Now, one thing that I do want to distinguish is between the difference of mass and weight. So mass is a measurement of the amount of matter, the amount of stuff that you have, and does not change. Weight, however, is the pull of gravity on an object and will change depending upon gravity. So if I go into outer space, my mass will stay the same, but my weight will change. Okay, so here I have 6 different examples of things, and I want you to think about whether or not they are made up of matter. So remember, anything that has mass and takes up space. So pause the video, go ahead and circle the ones you think are made up of matter, and then we'll go and move on in a second. Okay, so for the first one, a radio. If you think about this, it takes up space and it does have mass. It has some weight to it. So it is matter. Radio waves. Okay, so these travel through space, but they don't have any mass. So they are not matter. Textbooks, again, they take up space. They have mass. They are a type of matter. Now, fire. This is an interesting one that often gets confused. So fire seems to take up space or it occupies space, but it doesn't really have any mass. So fire actually is not matter. Now, the thing that is burning the wood, the charcoal, whatever, that is matter. But the actual flames itself, those are not matter. That is just an evidence of a chemical reaction occurring. Thoughts, similarly, they might take up space in your brain, but they don't have any mass, so they are not matter. And then air. Air, even though we're kind of used to it really not being there, it is kind of invisibly all around us. It has mass, a very small amount, and it does fill up the space around us. So it is a type of matter. So if you have any questions on those, please let me know. Otherwise, let's move on. Okay, so there are different ways that we can view matter. The first way is the macroscopic, which is also known as the large scale, or how we can see things with the naked eye. We don't have anything special to help us out. Then we have the microscopic. So this is the small scale, things that we can't see with the usual eye. We need tools to help us out. So in this case, it's going to be some kind of a microscope, like what you used in biology. And then submicroscopic. This is something that is too small to be seen by a normal microscope. So things like atoms and molecules. We might be able to see large scale if we group a whole bunch of them together, but individual ones we usually can't see with a normal microscope. So in chemistry, our goal is to relate these 3 different ideas. Okay, so we want to take the macroscopic, microscopic, and submicroscopic. And we want to use our knowledge of these things to help explain what's going on at the submicroscopic level and how that translates to what we see at the large scale or the macroscopic level. Okay, so let's go ahead and hopefully this is a review, but some states of matter. So we have 3 common ones: solid, liquid, and gas. So for volume, if you think about volume of these 3 things, well, for a solid, they have a defined volume. It will not change. And the same is true for a liquid. Gases, however, their volume will change because they're going to expand to fill whatever space they are in. So if you have a small container, they'll fill that small container. If you open up the container, they're going to expand to fill the entire room. Now, shape. Okay, when it comes to shape for these, only the solid has a defined shape. So for solids, they have a defined volume and shape. For liquids, they're kind of in between. They have a defined volume, but they take the shape of the container they're in. So if you have a gallon of orange juice and you pour it out to have cups of orange juice for breakfast, you still have a gallon of it. It's just in different shapes. And then gases, again, they will always expand to fill the container that they are in. So they will have a changeable volume and shape. And then here we have a submicroscopic view of what a solid, a liquid, and a gas look like. So solid particles are tightly packed together. They cannot move freely. They can, however, vibrate in space, which is how they are showing the energy they have. Liquids, they're a little bit more spread out, so they can go ahead and move around. Overall, they're moving a little bit faster, but not super, super fast. And then we have the gases. So these particles have a ton of space between them. And this picture really isn't accurate. Those gas particles are still way too close to really be a gas. They would have a lot more space between them, a lot more empty space. So I hope this helps. Hopefully it refreshes some things in your memory, or maybe you learn something new. If you have any questions on this, please let me know. Otherwise, thanks for watching, everyone. Bye.